Yep. Hi, everyone. I'm Richard. On behalf of Incubate and Software Craftspeople India community, I welcome you all for this session. Before we begin, a quick introduction about our community and our speaker today. So, SCI is a not-for-profit organization dedicated to connecting individuals with software craftsmanship mindset. Our mission is to foster a community where members can improve their skills and get better at their software craft. We organize talks, roundtables, and workshops aimed at enhancing the craft of software development. Throughout the year, we invite several industry experts to share their insights and expertise with our community. Incubate is the founder and sponsor of this community. And folks, Incubate is a company focused on delivering well crafted software solutions. About today's speaker, we have Michael with us. Michael is a seasoned IT professional with over 25 years of experience, an author and an internationally recognized speaker, blending expertise in software architecture with the artistry of magic and mentalism. His book, Mastering Software Architecture, reflects his deep understanding of the multifaceted challenges of building resilient, effective software systems and high performing teams. Michael's career spans roles from being an individual contributor to a CTO, with a particular focus on strategic architecture and holistic transformation. As a magician and a mentalist, Michael has captivated audiences in dozens of countries, applying the same creativity and problem solving skills that define his technology career. He excels in transforming complex technical concepts into engaging narratives, making him a sought after speaker and an emcee for tech events worldwide. Michael's unique blend of technical acumen and performative talent makes him an unparalleled force in both the tech and also the entertainment industries, driven by a passion for continuous learning and a commitment to excellence. It kind of looks like I can keep going on and on about our speaker, but to get the session started, I'm putting a stop over here. Also, everyone will be having a Q&A at the end, so you can keep your questions ready for after the session. With that said, Michael, we welcome you once again, and the stage is all yours.
Oh, thank you so much. Thank you for the lovely introduction. Good evening, everybody. Let me make sure you can see my screen. I've got chat up. Feel free to ask questions. But other than that, we are going to dive right in. Once again, thank you for the lovely introduction. I am Michael Carducci. I am many things, but today we're going to focus on what it is that I do, how I connect this to this idea of taking a more holistic approach to software architecture. I like to call myself a holistic software architect, and I really think that title grew out of an observation. That observation is, as I've worked over the last 15 years or so in largely architecture focused roles, and for the last 10 years worked as an independent architect, doing a lot of kind of consulting for organizations. One of the observations that I made was that as I begin to engage with a client, when they hire me to do software architecture, I spend a lot of my time working elsewhere. My last client that I was working with, they brought me in as an architect, but I spent the first few months actually of that engagement not really working on software architecture at all, but really helping them in other ways. And this is really where I adopted this title, holistic software architect, because at one point I felt like, well, I'm an architect. Why am I working on all these non-architecture things? But eventually I began to realize and I began to understand that it's all interconnected. There are so many different variables in the organization, the project, in the teams that all intersect, that all connect and become that deciding factor of how well you're able to execute that architecture. So to quote Douglas Adams, essentially what we are concerned with here is the fundamental interconnectedness of all things. The connections between causes and effects are often much more subtle and complex than we, with our rough and ready understanding of the physical world, might naturally suppose. And Dirk Gently was a character in a series of books by Douglas Adams And he had the same realization. He called himself a holistic detective. And it's the same thing. He said that he believes that everything fundamentally is interconnected. This is the fundamental interconnected. Oh, that's a hard word to say this early in the morning here in the US. The fundamental interconnectedness of all things. So like Dirk Gently, when I practice software architecture, I aim to find the whole solution. And a big part of that, I take this approach because, to paraphrase Dirk Gently, sometimes the trade-offs in software architecture are much more subtle and complex than we, with our rough and ready understanding of technology, and I mean all of us, might suppose. And ultimately, every single decision boils down to, what do we get and what do we give up? It's always a trade-off. There's never a perfect right answer that you can go to every time. That makes the work that we do in architecture challenging, but it also makes it valuable. This is not work that can be easily replaced. I learned years ago that there's a near infinite number of ways to write code that will deliver a set of features and functions. But the code is just a small part of the story. The functionality is just a small part of the story. In architecture, we're also interested in everything else that particular implementation gets us. And this is why even people who are thinking to themselves, well, in the future, I'm not going to be a coder, I'm going to be an AI wrangler. That's great, but you still need to understand how to solve problems. And you still need to understand how to compose a system that is going to induce the capabilities, the abilities, the right architectural characteristics for that project to be successful. So maybe the people who are excited about AI are right, and we're going to be orchestrating modules, then this stuff is more important than ever. And maybe they're wrong, and we're still going to, maybe we'll be augmented, but we're still going to be coding, and we're still going to be closer to the problem. Then this is still equally important because the variables are subtle and more varied and more interconnected than we might suppose in these trade-offs. So this is the skill. And one of the challenges of this reality that we have with the trade-offs, every single decision we make has consequences, good and bad. A lot of times, architects are only really able to develop a strong sense of how these variables interact over a long career. And that means we have to go out and make mistakes and have failures. And I don't think we can completely eliminate all of the failures, but I do believe that there are better approaches to software architecture. There are more reliable and deterministic approaches that don't have to be a crapshoot, that don't have to be a gamble, that don't have to be, well, let's try it and find out if it works or not. And that's really the idea of this talk today. I'm introducing a model of software architecture that helps you be more effective, that helps you navigate these trade-offs more effectively, and ultimately deliver an architecture that fits. Architecture is about designing for fit. Now, several years ago, 4 or 5 years ago, I created something called the tailor-made architecture model. And that's been developing, that's been written extensively into my book. But it's a way of delivering an architecture that fits, because success requires holistic fit. So I use this metaphor of clothing, particularly a gentleman's suit, because when you have a suit, it doesn't matter what your body looks like. You can be short, you can be tall, you can be skinny, you can be athletic, you can be rotund. But if you have a suit that fits you well, you're going to look good in that suit. And it's the same thing with the architecture. If you have an architecture that fits well, you're going to have a higher chance of success, at least with that software system, assuming the functionality is valuable. But the thing is, this metaphor really comes from my experience at a certain chapter of my life selling suits. And when I was selling suits, I realized very quickly it's not enough for that suit to fit your body. It has to fit your style and your wardrobe and the venue and the event you're wearing it to. There's a long list of other variables. And just like a suit doesn't only need to fit your body, architecture requires fit across a number of dimensions, including the teams that are actually going to have to implement it. That's a big variable right there. It has to fit the organization that these teams are working in. It has to fit the business goals. It has to fit the requirements, the business climate, and it has to be adaptable to the business future. Now, those bottom three, we can reasonably deduce these things, doing proper requirements analysis and everything else. And that's where we get free reign on that architecture to think deep thoughts about how we can best align a technology strategy with the business strategy and align how we're building that piece of software to the business goals, the business climate. And if we're very clever, we can actually not only align to those things, but leave ourselves a path for the future. Now, on the other side of things, the things that we can't control or are very difficult to control, those are the teams and the organizations. But, because to quote my friend Mark Richards, he says, if you don't have the right architecture in place, or you choose the wrong architecture for a given project, generally the functionality will work, but the application as a whole will not be a success, because it's not just what the software does, it's how it does it. It's everything else that software is capable of. This is where we're getting to the architectural characteristics like scalability and elasticity, evolvability and adaptability, and how architecture can enable or constrain organizational agility. So what we're going to talk about this evening, 5 challenges. The first challenge that we have is evaluating problem fit. The second is achieving deterministic outcomes. So often we'll design an architecture, but we won't know if it's inadequate until we've deployed it. Think about that for a moment. The first feedback that we typically get on software architecture is after the entire system is built. So what if we need to adapt? What if we need to pivot? What if we made a mistake? Could we, just like DevOps, we ask the question, could we have caught this issue earlier? Then we're going to talk about evaluating team and organization fit. How do we realize the constraints that we're working in, and how do we adapt and design for that? We'll talk about tailoring and fine-tuning architecture. And finally, I'm going to teach you how to communicate your vision for architecture in a way that doesn't set you up for failure, in a way that what you are imagining and what they are building are much more aligned than we currently achieve. Now, when we talk about architecture, and the reality is it's sometimes difficult to quantify, difficult to define. If you ask 10 different architects, what is software architecture? The odds are you'll probably get a dozen different answers. But eventually I came up with this definition. Architecture is the essence of the software, everything that it can do beyond providing the defined features and functions. It's everything else. But what do I mean by everything else? And where does this everything else come from? Because we generally conflate, we generally mix up, confuse these two things with architecture patterns that people frequently talk about in conference sessions and online sessions like this. Like, these are common software architecture patterns. And these are, or at least the mainstream patterns today. But I told you a moment ago that I believe that there is a near infinite number of ways to write code that will provide those features and functions. And in fact, if you give me a set of requirements, I can use any of these architecture patterns to build that application. They'll have the same functionality, but they'll have different characteristics, different architectural qualities, different, what I like to call, capabilities. And I arrived at that conclusion about the near infinite number of ways to write code when I sat in a conference session years ago, where our task was to write a single line of code, just one line of code. And as a group, we wrote that line of code. We expressed our intent in one line. And then he said, how else could we do that? And I realized that we were going to spend 15 minutes on this task, and it wasn't sufficient to come up with just one line of code. So we came up with a different way to express the same intent in one line of code, and then another one, then another one. And at first we were going slow. It was taking some time to think of a second or a third option. But by the time we were thinking of the 11th or 12th option, they were just coming out of our head. All of us, like we were coming up with new ways to write that same line of code faster and faster and faster. We were coming up with these ideas faster than the instructor could write them down. And that left me with the unshakable conclusion that, yes, there's a near infinite number of ways to do these things. So if I'm going to write this code, which pattern should I use? Well, again, it's all trade-offs. It just depends. Now, my friends Mark Richards and Neil Ford, they did something extremely valuable for the architecture community. They came up with a rating system on the scale of 1 to 5 stars, essentially communicating how well that particular architecture pattern is suited to delivering these kinds of capabilities. It was based on a lot of experience, a very broad sample of projects. And they rated all of these patterns that we're talking about. Now, I think this is a useful place to start, but it can be misleading. For example, if you look at this chart right now, you probably see one that looks like it's a clear winner in terms of the capabilities. And if you've been in tech for any amount of time, you know where I'm going, because everybody loves microservices. And everybody loves microservices because of what this comparison chart promises. Look at all those 5-star ratings. But that's not the question. That's not the problem that we're trying to solve. We're not trying to introduce the architecture that provides the most 5-star ratings. We're trying to provide the right architecture. And those two things rarely overlap. This is a formal software architecture anti-pattern called the out-of-context trap. Basically, this is blindly choosing the option that has the highest score or the most features or the most tick marks in the feature matrix without the context of the problem being solved. And Roy Fielding talks about this. He says some architectural styles are often portrayed as silver bullet solutions for all forms of software. However, a good designer should select a style that matches the needs of the particular problem being solved. Now, there's this idea that we can just avoid, we can just sidestep analysis and design through over-engineering, but that's not the reality. Now, I'm going to take a little bit of a detour for a moment, because sometimes it's easier to explore these ideas backwards, and sometimes it's easier to explore these ideas with more tangible examples in the real world, because this idea of metaphysics and software architecture can be a little bit abstract. So I'm gonna talk to you about a technology that offered many capabilities, that was objectively superior to its competitors, but ultimately it failed. Now, in the mid to late 1970s, we had the first mediums that allowed us to watch recorded video at home. Prior to that, the only way you could watch recorded media that wasn't live broadcast, but recorded media was either, the only way we could watch anything really in terms of visual media was either what was broadcast on TV, which was on a very specific schedule and you had to be tuned into the right channel at the right time, or you would go to a cinema, a theater. And again, there was a very rigid schedule. You had to be at the right place at the right time. Now, in the 1970s, we introduced magnetic media, the VHS cassette. And that was a tool that allowed you to watch pre-recorded video at home. Now, there was a superior option on the market that was introduced right around the same time. And I'm not talking about the Betamax format. I'm actually talking about the Laserdisc, the grandfather of our modern Blu-ray, and the ancestor to the DVD. Now, when we look at the feature matrix, because they were both available at the same time between the VHS cassette and Laserdisc, we could see that the Laserdisc had slightly better quality. It allowed you to jump to different parts of the video the same way you could do on a DVD or a Blu-ray. It had random access in a way that cassettes couldn't. It had chapters. It had special features, you know, interviews and deleted scenes and things like that that you could access. Had additional audio tracks, stereo and mono, different languages. There was digital audio that could be encoded onto that disc. That had interactive menus. And I thought about this when I looked at this comparison. I'm thinking, why was this other format not successful? It must have been price. But it turns out the players or the media, so the actual discs themselves, were less than half the cost of a comparable VHS. I thought, well, maybe it's the players. Maybe the players were just too expensive. But the players were actually cheaper as well. See, by every metric, that Laserdisc, which you may have never seen in your life, was superior. But so if it's so superior, then why back in those days was only one Laserdisc player being sold for every 50 VHS players there? At least here in the USA. I'm not sure about in India. The answer is because ultimately, no matter how clever it was, Laserdisc solved the wrong problem. It doesn't matter how good your solution is if it doesn't solve the right problem. The big problem at that time was being able to time shift, being able to record broadcast media and watch it back on your schedule. And only later did we think about just owning a catalog of these things. But at that point, we already had the VCRs, the VHS players in a lot of households. And I like this story because it shows how the most capabilities doesn't always lead to success. And the same is true in architecture. As Mark states, if the architecture doesn't solve the right problem, the project won't be the success that it could be. And so the question is, how do we know what the right problem is? How can we accurately determine problem fit for a given architecture? Because we have to make sure we're solving the right problem. And I had a friend of mine, a former colleague of mine, and he said he joined, he had a new job, and I asked him, I said, hey, Kevin, how's your new job going? He says, oh, it's going okay. It's not too bad, but I'm still waiting for the non-functional requirements from the business. And I said, yeah, you're going to be waiting a long time because they're just not going to give that to us. As architects, whether that's our title or not, part of our job is to figure these things out. Now, what we could do is we could just ask them. We can get a list of all these architectural illities and say, all right, which one of these do you want? But be very cautious in these situations, because doing that is a trap. Because if you do that, if you say, if you say, which of these do you want? They're just going to say to you, well, we want all of those. But because software architecture is nothing but trade-offs, there's no way that you can get all of those, because every time you make one of those illities stronger, you make other ones weaker. You can't just get more of everything. There's always that equal and opposite trade-off somewhere. So what is the process? The process is to have the conversations with the business. We start by preparing, locating documentation, project charters, pitch decks, specifications, metrics, whatever that is, and we start to infer what the requirements really ought to be. This is true whether it's a new system or a legacy system, and then identify the key stakeholders. These are people that are key people in the project who have some amount of authority and responsibility and accountability. And I want to get those people together. Sometimes they're the people who write these documents. Sometimes they're project leads. Ooh. Excuse me. But we want to get those key stakeholders together. Then we can have the business conversation. This is where we find out what their vision is, and we come up with an architecture that aligns with it. We document, we design, we document some more, we design some more. Now, one of the key things you've got to understand as well is that the business doesn't speak the language that we speak as architects and as developers and as technologists. So part of what we do is we're translating their vision into the language that we natively speak. We translate the requirements into those architectural capabilities. So one of the axioms in this model is that the most important thing is fit. And fit doesn't always look the way that you expect. Let's look at a quick case study. So you're joining a project as an architect, and they say, hey, we're a startup, we need agility, and we're going to be huge. Okay, that's not a lot to go on. So if you were given this kind of high-level vision and you were thinking about architectures, what would you, where would you go? Would you jump directly to microservices? Would you build a monolith? What we need to do is qualify the capabilities, qualify what we mean by agile and huge and everything else. And there's also some interesting text in the fact that they are a startup. Now, our particular startup is the Web 2.0 wunderkind that was Twitter back in 2006. They launched a set of features and functions that were successful. They were a hit. And in fact, it didn't take long for this to happen. This is the overcapacity page that would show up very frequently in the early days of Twitter because it was overcapacity. It was crashing many times a day. So the features might have been great, but those architectural capabilities were lacking. What were we missing? Well, scalability, elasticity, throughput, fault tolerance, and availability. Now, ultimately, Twitter spent the next couple of years redesigning and rebuilding their entire platform in a way that delivered these capabilities. So the fact that they needed to do a very large rewrite really brings us the question, well, if we had to rewrite it, does that mean we did it wrong the first time? And the answer really is not a clear yes or no. It's like all things in architecture, the answer is it depends. Because like I said, fit doesn't always look the way you expect. So that first version of Twitter that was built initially, that was designed for certain capabilities. And the second version, the new version, when they rebuilt everything, that was designed for different capabilities. So those were different sets of priorities at different times because they were a startup. They really couldn't engineer to that level. They didn't have, you don't have enough money to do that. You don't necessarily always have enough time to do that. And sometimes the highest value that you can deliver in software is not a perfect platform, is not a perfect architecture, but just the answer to a question. Is this product, is this app, is this thing even going to be useful? Is it even going to be valuable? Because every decision in architecture, and this is ultimately why every decision in architecture is a trade-off. Fundamentally, version 1 and version 2 of Twitter traded certain capabilities for others based on relative business value at that time. Now let's actually talk about what this might look like. An example project. Now I've got a fairly typical looking business vision. There's a lot of buzzwords in there. You don't actually have to read this, but this is kind of an example of the type of thing you might see, especially in this new, very data-driven age. Part of what we do to get these requirements is we read it, but we don't just read it. We have to read between the lines. We draw on our experience to figure out what they're trying to communicate, but not saying. We'll ask questions of the business as well. So when we look at this project, one of the key things that we want to begin to tease out is, okay, what capabilities does this system need, and what are the priorities relative to the other ones in this project? We want to rank and prioritize the capabilities because that's going to help us navigate the trade-offs in the future. So we look at this project, we see, okay, in order, these are the abilities that matter the most. Now, if we use the Ford Richards model of their capabilities with the scorecard as a start, we can rank them and compare. But there's a lot of trade-offs in this ranking. So we look at this and we say, okay, Our most important is here. Our second most important is here. Our third most important is here. Fourth is here. Fifth is here. And we look at those top five and we can just start to see, well, what's best? And then we look at that old orchestration-driven, service-oriented architecture. We say, we're not going to do that. So you look at the second best and we're back to microservices and event-driven. The same with interoperability. We're not going to do that. So we end up back at microservices and event-driven. For the fourth one, agility, well, microservices declare winner here. And event-driven is only 3 stars. And then the fifth one is testability. So we look at this, and service-based is not bad there on testability, but ultimately everything seems to point to microservices, right? It's not a perfect fit, but it's close. Now, with this new model that we're talking about today, you're not limited to just 5 capabilities. You can look at the whole complete picture, but we're looking at microservices. Now, here's the interesting thing, though. When I was giving a session and I showed this diagram, there was an attendee in the audience who sort of stared at it for a little while, and I could see he had a question, so I asked him to ask his question. He said, are those architecture ratings broadly accepted in industry? And I thought that was a really insightful question, because clearly these star ratings didn't align to his experiences. And that means your mileage may vary. In fact, it almost certainly will. I can't tell you the number of people I've seen who build microservices expecting this, but the reality, once they're built, it looks more like this. Where did all those 5-star ratings go? In other words, but why though? And the answer is because breaking an application up into hundreds of tiny pieces doesn't magically make all these capabilities appear. And so the next question then is, where do those capabilities actually come from? They don't come from the pattern. And because they don't come from the pattern, but we treat architecture like they do, we end up getting very non-deterministic results. Sometimes, we build the same system multiple times or design the same system multiple times, and the results are wildly different. And so the question then that we need to solve, the problem we need to solve, is how can we more reliably and deterministically elicit system capabilities from architecture decisions? Because as I've mentioned already, architecture is not deterministic right now. And part of the challenge is that we have a very simplistic way of categorizing our architectures. It basically boils down to, is it a monolith or is it microservices? And everything on the right tends to get called microservices, or most of the things on the right tend to get called microservices for one reason or another, even though they're very different. And everything on the left is a monolith, and we generally talk about monoliths as being bad. But more realistically, there are things in there in different monoliths. The only thing that's bad in any architecture is the wrong set of trade-offs. But because we have this model of this flat categorization scheme, this flat taxonomy, we start to associate the capabilities of the system with the topology of the system. They're like, oh, well, yeah, we break it apart and suddenly everything's like microservices. Or we keep it all together and it might as well be a big ball of mud, which is not true. We need to be thinking about the underlying decisions that lead to the pattern in the first place. In other words, I think a very important thing to understand, regardless of where you are in your career and what your real title is, if you're building software, remember this: patterns aren't architecture. Choosing a pattern is not architecting. This isn't architecture. Fundamentally, the patterns are just a side effect of architecture. When you do the work of architecture, occasionally repeating patterns emerge, and those can be useful as reference points, but it's all about doing the actual architecture. Now, this doesn't mean throw away your patterns, but it means think about how you're approaching the problem. There are many paths to building a suit. There are many paths to designing an architecture. Let's just look at one capability as an example: evolvability. Evolvability is the ability for a system to gracefully adopt and absorb both business and technical change. This is a characteristic that is supposedly very strong for patterns like microservices and very weak for patterns like monoliths, like the layered monolith, Like if you look at this on their scale, it gets 1 star of evolvability. But the reality that we live in is that we build sometimes microservices that are evolvable, and we build microservices that aren't evolvable. We build event-driven systems that are evolvable. We build event-driven systems that are not very evolvable. And we build monoliths that aren't, and we build monoliths that are. So there's more to architecture than just patterns. And in fact, at the heart of it, it's decisions. You see, every project involves a lot of decisions. Every time you're in a software project, there are a lot of decisions that are going to be made. Some of them you're going to be making, some of them other people are going to be making. Some of those decisions were made maybe before you even joined the company. But if this circle represents the set of all decisions made on a project, there exists a subset of those decisions that directly impact the architectural capabilities and their measure. Now, I realize the meme that I have is very old. Nobody who's cool is doing it anymore. So while we're on the subject of outdated memes, what if I told you there is a way that the key decisions could be defined and codified into these reusable atomic building blocks for architecture design, that you can approach architecture not through blind, naive pattern selection, and not by reinventing the wheel from scratch every time, but a very powerful third option where we're able to compose an architecture out of decisions and understanding the impacts and the trade-offs of each one of those individual decisions. So as we're bringing those in, we're making a more reasoned and a more nuanced set of decisions to arrive at the architecture that's really going to bring value. You get deterministic and predictable outcomes. Well, you might not believe me, but think about this. Where do the architectural capabilities actually come from? Like I said earlier, breaking an application up into hundreds of tiny pieces doesn't magically make all those things occur. If they did, I wouldn't have had a job for the last 10 years as an independent architect, helping people figure out why all of the promises they got at conferences and out of books and everything else didn't materialize when they actually built their software, because they naively believed that the capabilities came from the topology and the patterns. But those capabilities don't come from the pattern. They come from the decisions that make up the pattern, and specifically the decisions that are constraints. Constraints are really the key here. To get those architectural capabilities, the architectural ilities, the system quality attributes, whatever you want to call them, we actually get those by applying constraints in the system, constraining the degrees of freedom that are available to the implementation teams that are actually building the system. So this idea that capabilities are elicited by constraints can be a little bit abstract. So I'm going to start with a concrete example that I imagine most of us are familiar with. Those are the solid principles. Solid's a mnemonic coined by Michael Feathers to kind of codify some of the ideas that were introduced in 2000 by Bob Martin in his Design Patterns and Design Principles paper. But let's just look at this. If we kind of look at a neutral set of capabilities, and maybe we just focus on one of those. We look at our maintainability. As soon as we constrain that a class can only have a single purpose, look what happens to that bar. Our maintainability goes up with that constraint. It improves maintainability along with some of the other capabilities. Now, if we look at our extensibility and modularity, these are improved when we bring in the open-close principle. Our code becomes more extensible and easier to test. Now we can look at adaptability and modularity and see what happens when we apply the Liv-Skov substitution principle. We can look at adaptability and testability when we add the interface segregation principle. And we can also look at the testability, what happens to that when we apply the dependency inversion principle. So in essence, this set of constraints will take a system from here to here. You're just reducing the degrees of freedom to force the code into a certain state that will induce these properties. Another example is the infamous big ball of mud architecture. The defining property of a big ball of mud is there's no rules, there are no constraints. You can make everything public if you want to. You can make everything global if you want to. You can put it all into one method if you want to, with go-to statements and everything else. It's a free-for-all. Anything goes. But what capabilities come out of the big ball of mud? Not many. But as we constrain the degrees of freedom, and we get more constrained as we move to very sophisticated architectures like microservices is highly constrained. And then there are more practical, kind of balanced approaches as well. Now, this isn't a new idea. In fact, I learned about this idea from Roy Fielding's 2000 doctoral dissertation, Architectural Styles and the Design of Network-Based Software Architectures. Now, if you're like me and you actually read this paper, the odds are you're like me, and the first time you read it, you skipped directly to chapter 5. Why chapter 5? Well, that's because that's where he talks about REST. Most people that I know who have read this paper have only read the chapter where he talks about REST, but it wasn't about REST. And this is why it wasn't really useful when people were reading this paper trying to figure out how to better design their APIs, because I'm not going to go into this, but REST also has nothing to do with APIs. It's just an architecture that you can apply to your APIs. But when you read the whole thing, it's extremely eye-opening, and you realize this idea of architecture designed by constraint isn't new. He heavily cites the book that came out in 1992, Foundations for the Study of Software Architecture. I mean, we see echoes of this in 1975 in Fred Brooks' Mythical Man Month. And the thing is, we got this whole timeline of these, of experience learning the ideas around constraints. And the thing is, it's not new, but it's also not old. It was when these ideas first came out, there were ideas that were ahead of their time, and there are ideas that are still valuable. Remember this, in our industry, not everything that is old is obsolete. There are things that get old and become obsolete, but more often, there are many ideas that are so valuable, they are timeless. This is one of those timeless values. What I discovered, though, in addition to this idea that's been shown to work again and again in theory and in practice, is that with the ratings that we got from Ford and Richards, these constraints can now be weighted by their positive and negative impacts on the capabilities. So this really changed the way that I look at software architecture. And one thing that Magic has taught me is that when you change the way you look at things, the things that you look at change. So when I look at these patterns, as diverse as they are in terms of implementation and topology and capabilities, each is just the result of only a handful of architecturally significant decisions. Behind the curtain, just a bunch of decisions that each positively and negatively impact the capabilities of the system. Now, we can look at our example project. We can convert all these prioritized capabilities into targets like this on the grid. Now, you can have as many as you like, but the thing that you have to remember when you're following this process is no two targets can occupy the same spot. So let's see if we quantify these capabilities. How do microservices stack up? Well, alone, they don't get us to where we need to be. You can see that we're coming up short in a couple of important capabilities. So we need capabilities around integration, interoperability, and workflow. Now, since the capabilities come from constraints, we can actually add more constraints to this architecture. And you can start to see how it becomes a really powerful model. So, for example, we're shy on the workflow capability. How can we improve workflow? Well, we can bring in some of the defining decisions in an event-driven architecture that is very well suited to this type of work to create a hybrid event-driven microservices. We do that by constraining that service-to-service communication takes place using a pub sub. So it's gonna improve our workflow, our cost, our abstraction, our performance, but it's gonna hurt elasticity in some places. It's gonna hurt testability in some places, deployability, and configurability. Now, what about these other two? There's other glaring holes in here. Well, there's some useful work here that can help us out around the REST architectural style, around the resource abstraction that's prescribed in REST, and we can build on that and use the resource description framework and use that to represent our data, which is designed for web scale integration of heterogeneous data sources, and it supports complex semantics. It improves our abstraction, our integration, and our interoperability, but it's going to hurt our simplicity. It's going to hurt our performance. And you can start to see the power of this model. The thing is, holistic architecture is more than just constraints and capabilities. Again, we have to look at everything because everything is connected. This is why we need to talk about how to evaluate for team and organizational fit. The tailor-made architecture model connects defining architectural constraints to the demands that it's going to place on the team. Let's look at one of these highly constrained architectures. Let's look at microservices because, as I mentioned, this is a very constrained architecture. Now, microservices emerged a little over a decade ago, and it didn't emerge because somebody finally discovered the secret that it was one of those, because there's one of those ideas that was just sitting there waiting to be discovered. It wasn't a sudden realization that tiny components are some kind of panacea. In fact, if you traveled back in time, maybe to the late 90s, maybe the early 2000s, and proposed this architecture, people would look at you like you were crazy because it's not a radical idea. At that time, it was impossible. It was only enabled by a number of X factors. X factors are the hidden variables that lead to the success of microservices. So the pattern itself and its defining constraints, they can't operate effectively without the X factors. Then those X factors drove development and the success of this approach. One of them was a recognition that we don't build software. We like to think that we build software, but I'll tell you right now, we don't. We don't build it, we change it. Software development is just a deeply nested set of change cycles. I learned that from Dave Thomas, one of the signatories, of course, of the Agile Manifesto. The Agile Manifesto was a call to industry that to begin to recognize this fact and embrace new methods to facilitate change. What the Agile Manifesto, before we got SAFe and all these Agile frameworks and all of this pseudo-Agile nonsense that a lot of us do in our jobs every day. But in the beginning, the core was a realization that we were optimizing for the wrong things. We were optimizing for construction instead of optimizing for change. And that was hurting us. It was hurting our customers. It was hurting the industry. So the Agile Manifesto was a call to the industry to embrace new methods to facilitate change. That was an important step. And around the same time, we had emerging practices, Agile technical practices, things like test-driven development that was introduced by Kent Beck. He gave us tools for fast feedback and on functionality and correctness. We developed techniques around continuous integration, continuous delivery, and the rise of DevOps. These were enabling operational automation, enabling us to construct faster feedback loops. And of course, such a modular architecture as microservices, where everything is broken apart, requires very precise module boundaries. And this is where we realized that we had been constrained by Conway's law, but the domain-driven design community, and Eric Evans in particular, gave us tools to begin to navigate that complexity, because what we learned in 1967 with Melvin Conway and Conway's law is that it doesn't matter what architecture you design, you're going to ship something that looks an awful lot like the organization chart. But you can't deal with that until we had tools like domain-driven design. And so if organizations ignore everything that made microservices possible, the reality is they won't be possible in that organization. So if we look at these, we've got microservices described as highly decoupled, independently deployable, fine-grained components that are grouped by domain and partitioned at the bounded context, facilitated by some kind of API interface, running an environment that has high operational automation. What does that demand? Well, it demands the company makes the investment into DDD. This decomposing is more than untangling code. It's figuring out the module boundaries at a granular level. So this requires not only investment into DDD to uncover the natural seams in the business and the supporting software system, but the thing that we need to keep in mind, this is only possible if the organization has well-defined domains. You have to do this work, but that's not enough, because Conway's law was clear. It doesn't matter how you carve up your system, you're going to ship the org chart. So if you want microservices to work, it better be the right org chart. And this is not typical. This is not how we normally design organizations. We build feature teams. We build teams with a certain technical expertise. Microservices requires changing that. An organization with domain-aligned teams. We need sophisticated development teams that can handle the trade-offs that are inherent to such an extreme approach to decoupling and modularity. Like, there are times in microservices where you need to violate dry. And for some people, dry is a religion. I'm going to dry no matter what. If I see any duplicated code, I'm going to dry that out. Don't repeat yourself. Don't repeat yourself. That's great, but it's a trade-off. As soon as you're creating these shared libraries or shared services, you're introducing coupling. And microservices decided we don't want coupling. We're going to get agility by taking a very extreme approach to decoupling all these things. And developers that might be smart, that might be capable, they might be incredible coders, but they can't understand the limits to the rules and when to break them. They're going to go back to their normal patterns, and the promise of microservices is not going to materialize. We need a mature development process, produce the software in a manner that is aligned with agile principles, mature testing strategies, things like that. We need high automation in the process. This is a bunch of secondary. Now we're getting a bunch of secondary skills that maybe very capable developers might not have. If they don't have those skills, then as an architect, if you're prescribing something that the organization doesn't have the skill set for, you're setting the organization up for failure. We need an organizational commitment to DevOps. The teams need to be able to work completely independently. And these are very advanced practices that don't come naturally to most people. We end up coupling our teams together. We couple our cycles together. We have to be careful around that. CI/CD pipelines. We need an environment that enables high operational automation. Maybe that's the cloud, but the cloud's not just going to give it to you for free. So all of these constraints here, these are all part of fit. And what they really boil down to is they are non-architectural constraints. These are the constraints that constrain our degrees of freedom as architects, that we either have to work within those or we have to work to change those things in the organization. Their team constraints, their organizational constraints, and their environmental constraints. So team constraints, excuse me, are things like skill and maturity. And I don't mean are they skilled or are they not skilled, are they smart or they're stupid, but does the team have the skill set necessary to execute your particular architecture? Like I was talking about with microservices. There are new skills that even a lot of seasoned senior developers might not have. So you need to be mindful of this. Where are we with automation? Where is the organization with their priorities? Because if you've got one set of priorities and the teams have another, they're gonna make sure they're taking care of themselves before they're worrying about what's in Lucid, what you put in Lucid. The hierarchy of the organization, these are all things that constrain the teams. In the organization, we have things like budget and timeline, and do we have those well-defined domains? Do we have domain-aligned teams? And then the environmental constraints, these are things like the complexity of the solution space, the sway and influence that you might have to drive innovation in the organization, the infrastructure maturity, the deployment maturity, the openness to new ideas in that environment, autonomous development environments, things like that. So we need to be more holistic when we think about the architecture. We have to consider all of these things. So when we look at our example project and we see, we see, okay, well, this looks on paper like a reasonable fit. We're maybe over prescribing a little bit in some areas, we're under prescribing a little bit in others. It's pretty close. That said, if you look at the realities of the organization, you see they have low infrastructure maturity, medium infrastructure or automation maturity, complex problem space, feature teams, aggressive timelines. They haven't done the DDD work and they don't want to reorg. Then ultimately your architecture is going to fit about as good as this suit. Now, obviously this doesn't fit. Can we find a better fit at design time? And the thing is, like, this problem of fit right here, most people don't run into this until the project is already built and deployed. But could we have figured this out at design time without extensive trial and error? Well, yes, because every single one of these constraints has the trade-offs expressed in the model in the book. So we can start to fine-tune and we can change the constraints and we get a different outcome. And this is something that's actually going to be much more aligned to the complexities and the realities of the project and the teams and everything else. So hopefully you're starting to see how this approach allows deterministic and fine-grained control over the system. Here we're adopting more coarse-grained architecture with a pub-sub data backplane, right? It changes. This is within reach of the organization, and it still fits the requirements. It's simple, but it's not easy. So to kind of close and wrap up, just some things to think about. Avoid over-prescribing constraints, especially not in architecturally significant areas. Don't under-support the constraints. Don't be an ivory tower architect. Actually build consensus, get buy-in for these decisions that you're prescribing, because you're not ultimately the one building it. How are you going to support these things? So if you're prescribing a constraint, excuse me. If you're prescribing a set of constraints, every time you prescribe something, ask the question, how are you going to support it? That's part of our job as architects. How are you going to enforce it? Because you can't stand over every developer's shoulders and make sure they do it right. Think about automation, think about governance, think about architectural unit tests and fitness functions. Ask why, think about learnability. So the last thing I'm going to talk about, though, so you've balanced your architecture, you've designed it, you understand the requirements, you've done all of the work, and now you need to communicate that out to the team. One of the problems with that flat taxonomy that we have is a lot of people refer to very different systems using the same architectural labels. For example, and they're so widely used and so diverse in their usage that if you just said, oh, we're building microservices, you'll end up with a bunch of developers picturing something different, but they think that they're in alignment because they're using the same word. In fact, most people, to them, microservice just means multiple components that are running in their own process space. And so they see any distributed architecture and they link to, oh, microservices. But there's a more precise way to communicate this, and we can borrow from the people that we can stand on the shoulders of giants. We can borrow from the people who came before us. We have this idea of an architectural style, which is a named, coordinated set of constraints. I'm quoting Roy Fielding here, but Perry and Wolf in '92 talked about this. It shows up a lot. And what that means is instead of a bunch of little patterns, a handful of patterns, instead of a small number of patterns, we have a vast taxonomy of architectural styles. And here's the beauty. You don't have to memorize what they all are. You don't need a book for every single one of them, because it's not a bunch of stuff to memorize. It's a new way of thinking about architecture. There are tools and approaches that allow you to discover one or create one that is tailor-made to your project's needs. Once you've done this, because an architectural style is just a set of constraints. When you've defined the set of constraints for that part of your system that has a specific discrete architecture, then you bring those constraints together and then you can name it and describe it in something called an architectural style document. This document is part of the process. There's a lot of links to in this example documents to things like architecture decision records, other things, and all of these are part of an architect's tool set that is available on my GitHub, github.com/Carducci. There's a tailor-made workshop repo in there, and you can grab some of these templates and some other things if you want them. But we've got to wrap up. We're coming up to the end of time. I hope you can see this as a powerful model. I hope this gives you a new tool to think about architecture and get more consistent results. And also, if you are excited about AI augmented coding, if you've done any amount of it, then you've seen these models do absolutely bananas things. And if you're not careful, it'll drop your production database, or worse, exfiltrate, credentials and crypto wallets and all kinds of passwords and session cookies outside of your environment, because they're also being used as attack vectors. But the problem fundamentally is the models that were the AI models that we're using to augment code have too many degrees of freedom. So this is useful in classical approaches to building software, and this is even more essential if you're very excited about AI augmented code and things like that, because everyone needs to constrain our models. But we are out of time, so I will say thank you. I've got 2 QR codes here. The very fancy one will take you to my LinkedIn. Feel free to connect. I've got some interesting projects and things coming up. I'm going to be announcing those on LinkedIn in a couple of weeks. If you're interested in deep diving into this model, my book is available on Amazon.in, and that QR code will take you to, I hope, I actually haven't tested it, but it should take you to the local Amazon where you can get hold of that book. And also just reach out. This is my contact detail. Michael@magician.codes is my email. You can follow me on Mastodon, and soon you'll be able to follow me on YouTube. I don't have a link there yet, but there is a new YouTube channel coming, and I hope I see you in some of these different places. But on behalf of everybody here, I want to thank everybody who joined us, and I particularly want to thank the Software Craftspeople India for the invitation to join me and spend the evening tonight with you. So thank you all so very much.
Thank you, Michael. That was an interesting talk. So, folks, we are just opening up for the Q&A. If you have any questions, feel free to unmute yourself and then ask that.
But not all at once.
Yeah, I'd like to ask first. Hey, Michael. Yeah, I just
Sure,
sent a question on the. Hi. So when you talk about, you mentioned to avoid over-prescribing constraints. So how do you know you have hit the balance?
That's a great question, and really, the approach to addressing that is to keep continuously asking the question, why? Why am I prescribing this constraint? Try to trace it back, like the process that I go through to get the requirements. When I'm talking to all these people, I'm trying to find out what their pain points are, what their fears are. I'm trying to find out kind of what these key, what matters. I'm trying to find out in that process what is enough of an architectural capability. It's like if you've got a system that's got kind of bursty traffic, maybe at certain points of the day there's 200 daily active users, and then at other parts of the day there's 1,000 daily active users. Or maybe you'll go from not daily active users, I'm sorry, maybe like off hours there's 50 concurrent users, and at peak hours maybe there's 500 concurrent users. That's great. So that actual data allows you to try to determine where you really want to design for. Because if you're talking about 1,000 concurrent users, you don't need to engineer Google. And in fact, one of the things you learn with this model is maybe you're going to get Google size, but you don't have to engineer Google on day one. You can build evolvable architectures. But it really comes down to going through the process to quantify what is enough of any capability and try to get enough. We want enough, not a lot. A lot is over engineering. We have accidental complexity. But if we have this idea of enough and we understand what the trade-offs are, and we can validate that those ilities are necessary, then that helps us know that we're not just over engineering at any point, but we're making kind of good reasoned, data-driven decisions. So it's just kind of qualifying those capabilities. Am I sure I need this? Quantifying that capability. How much do I need? And why do I need it? Answer that question, why? Not because faster is better, not because bigger is better, but because it's going to translate into tangible business value. But that was a great question. Thank you very much.
Thank you for answering. That makes a lot of sense. Thank you.
Pleasure. And I know it's getting late into the evening, so it's 8 o'clock now. Is that right? 20?
7.
Oh, my time zone keeps changing. Sorry, I'm traveling right now. That's why I'm in a hotel room. But 7 p.m. Okay, yeah. So I know it's getting late, but happy to answer any more questions that folks might have. Okay.
So, yeah. Thank you to all who have joined us today. And Michael, thanks a lot for taking your time out and then doing the session for us. So, folks, if you have missed any of the part of the event, do not worry. The entire event has been recorded and it would be available in our YouTube. And we would also be sharing it in our social media handles. Also, please join our WhatsApp group for timely reminders so you do not miss out on any other upcoming talks. Our next session will feature Christian Hugo, where he will be discussing on Agile without buzzwords, what really works. So we hope everyone to see you over there. Sharing a few links in the chat on our WhatsApp and our social handles. Please do follow them so that you do not miss out on any other sessions. And Michael, once again, thanks a lot for taking your time out and then doing this. So thank you, everyone. Have a good day.
Thank you. And if you think of a question later, feel free to email me. Or reach on LinkedIn. You've got my contact. I'm always happy to continue this conversation. And thank you for having me. It's been a real pleasure and an honor to be with you all tonight.
Thank you. Bye.
Thanks, Michael.
Thanks, Michael.
Thanks,
Thanks, Michael. Great session.